race to win wars and explore the stars, have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. The flag, a simple piece of cloth that has huge symbolic significance. The Hovercraft, the science behind this transportation marvel. The gym machine, introduced by the Greeks and still keeping us fit today. We reveal the amazing science and manufacture behind these wicked inventions. Flags, arguably one of the most common signs of pride in one's nation, team or event. Flown everywhere from sports stadiums to seat of governments across the world. We are familiar with these colourful banners, but are often ignorant to their military origins.
If you look at flags being used in war, you've got to go right the way back to the ancient times, to the Roman standards and their eagles. They're rallying points. They're the identification of their legion. When you follow it through, the Saxons at Hastings, they had their standard right to show where Harold was. Still to this day in the army, we have the colours of the regiment, and they are a rallying point, the pride of your regiment, the pride of your army.
Countless stories exist of blood-soaked fights to protect the flag. Medieval Lord Cheney at the Battle of Bosworth Field in 1485 was run through by King Richard III whilst he bore the flag of his master, Henry Tudor. Even as late as 1879, the gallant exploits of Coghill and Melville were celebrated as they lost their lives trying to deny the victorious Zulus their regiment's colours at the Battle of Isandlwana.
It's so serious if you lose your standard. And when our standard was lost the 24th of Foot in the Zulu Wars at Isandlwana, when they managed to recover the standard, it became so prestigious, even though it was falling apart, because it is the symbolic heart of your regiment.
Flags were even more important in their use at sea, with huge ensigns displayed in battle, which identified each side's ships amongst the clouds of gunpowder smoke.
One of the most interesting parts of flags in warfare is the navy, but also they could be used in subterfuge. You want to get close to the enemy, run up one of their flags, but of course when you're going to engage them in combat you must run your own flag up, otherwise it's bad form.
Sailing under a false flag is still an accepted tactic in modern naval warfare, and it was at sea that flags were used in an early form of psychological warfare. The pirates' notorious skull and crossbones, known as the Jolly Roger.
They had individual Jolly Rogers, and when you saw that coming towards you, that flag was hoisted, you'd be terrified. And even today, there are certain terrorist groups around the world who have their own flags, which are quite intimidating, quite terrifying to people.
Irregular groups also have the need for easy identification, as much as any patriotic army. Revolutions are, by their very nature, fast-moving and confused. When Parisian militia started wearing hastily assembled red and blue cloths in their hats during the storming of the Bastille in the French Revolution of 1789, the white and gold royal standard of King Louis XVI was cast aside in favour of the victorious tricolour of red, white and blue, a design which still inspires pride in the hearts of the French even to this day. Other flags are even more pronounced. The modern flag of Mozambique, for example, carries not just traditional bands of colour, but also the image of an AK-47 assault rifle, signifying the country's struggle for independence. So, a piece of cloth born on the bloody battlefields of history, but identifies a myriad of uses and organisations today. The flag, truly a wicked invention. JW Plant & Co Limited are a fourth-generation family business and have been making flags in Leeds, England since 1908.
It started off primarily as a cut and sew, a flag making company where we take individual pieces of material, cut them down, sew them up to make national flags and corporate flags and various other insignia flags. In the early 70s, we started to add screen printing, and then in the early 2000s, we added also then digital printing in, and we're now one of the few manufacturers in the UK that still have the facilities to make cut and sewn, applique, screen print, and now new digital printed flags.
The flag design, in this case the Scottish Standard flag, is loaded into the computer-aided design software, and the correct colours are assigned and checked against the design. The design is then sent to a large format inkjet printer, where it is printed directly onto the fabric. The printer can print 1 metre in 1.5 minutes.
In the UK, we tend to manufacture most of our flags out of polyester-derived fabrics. It's got very good wear properties, it's washable, and it keeps the subtleties of lots of the older materials.
The printed design is then fed through a heating oven in order to dry and bond the inks onto the fabric. The temperature of the oven is approximately 200 degrees Celsius. The printed fabric is pinned and stitched onto a backing cloth around the edges of the design, sandwiching another piece of cloth in between, which will form the main background colour of the flag. Waste material is then cut away from the edge of the stitched design to form a relief pattern. The outer edge of the backing cloth is also trimmed off. A second panel is also prepared in the same way, which will form the reverse side of the flag when it is complete. Next, the edges of the flag are measured and marked for hemming. The flag is then hemmed all the way round the edge using 2 rows of bonded nylon thread stitches.
Our threads now tend to be in an applique procedure, 100% polyester, and in a seaming procedure, it's now strong bonded nylon.
There are 8 to 10 stitches per inch. A tasselled border is also carefully sewn on around the edge of the flag. Next, the reverse side panel of the flag is pinned into position. The panel is then hemmed and sewn onto the reverse side of the flag, completing the process.
A certain size may require 2 hems or 2 rows of stitching. As it gets bigger, it will be 3 and then 4, and you're still governed by the number of stitches per inch. This is all in a bid to try and secure the outer perimeters of the flag.
So, there you have it, the flag, used for identification around the world for over 5,000 years. Now that's a tried and tested, wicked invention. The Hovercraft is a machine that defies the terrain it travels on. Hovering friction-free, it is able to travel at high speeds in ways that boats, trucks and cars cannot. This incredible machine is capable of travelling over a wide variety of surfaces. Their amphibious versatility has seen them adopted by the military due to their ability to carry large cargo loads and the fact that they are able to land on almost 3/4 of the world's coastline.
Hovercrafts can cover many terrains: water, mud flats, sandy beaches. It can go over obstacles, generally of a few feet high. It can cross a gully of about 4 feet and still maintain the skirt and move forward. So it has lots of applications where the ground terrain simply isn't good enough or there is no infrastructure.
Their versatility comes from the fact that they effectively fly just inches above the surface they travel on. So what is the magic behind the hovercraft's ability to fly? A hovercraft is made up of a body, powerful engines, fans, rudders and a flexible rubber skirt. The ability to hover comes from a large centrally mounted fan that blows an enormous amount of air under the craft. As the rubber skirt creates a seal with the surface beneath the craft, it starts to inflate. The skirt size dictates how high from the surface a hovercraft will rise, with excess air escaping from the skirt once it has reached its capacity. The flexible skirt also has the ability to bend round obstacles on land and water. With the hovercraft sitting on a frictionless cushion of air, the rear fans can then be used to propel the craft forward, with rear rudders providing the steering by channeling this backwards blown air from side to side. The earliest design for a hovercraft goes all the way back to the 1870s. A British shipbuilder, Sir John Isaac Thornycroft, patented a design for an air cushion ship. However, his design could not be manufactured since a powerful engine was needed, and that was not around until the 20th century. A visionary of his time, Sir John Isaac dreamt of a ship that did not require much force nor power to achieve great speeds. It was, however, not until the 1950s that the air cushion ship designs were picked up again by Christopher Cockrell, a British mechanical engineer. While studying the ring of airflow when high-pressure air was blown into the area between two tin cans, Cockrell realised the sheet of fast-moving air presented a type of physical barrier to the air on either side of it. He called this effect momentum curtain. He decided that this effect could be used to trap the air inside a barrier. This meant that with a small amount of active airflow, it was possible to produce lift. With his revolutionary design, Cockrell had created the modern hovercraft. The hovercraft became a commercial vehicle when the SR-N01 managed to cross the English Channel in 1959.
The first demonstration of the hovercraft with Christopher Cockrell was across the channel between Dover and Calais, and he showed that it could work as a viable product. He realised then that the skirt that he had needed to be more flexible because it had problems of dealing with waves that are about a foot, that's 30 centimetres high, and realised you can't cause problems because it needs to permanently be able to partially collapse and then reform. So only a few years later, he had a product that would work with 6 to 7 foot high waves and could cross the channel and became a viable commercial product.
Because of its success as a commercial vehicle, the US Army decided to use it in a trial during the Vietnam War in the 1960s. The flexibility of a hovercraft has led to armies worldwide adopting this fantastic machine for a variety of tasks.
I think the military usage of it looked briefly at what could be done, but it took some time for the full benefits to be realised. And certainly today, from a military perspective, certainly the Americans and the Russians can absolutely see its utility. Largely in the littoral warfare or riverine areas either close to the land and the sea, or marshland where you want to put in either a load of troops or tanks and vehicles quite quickly, because hovercrafts are very fast. So to put a rapid high-speed incursion of troops or vehicles onto another shore is clearly one of the big benefits and attractions of using them in a military context.
Today, this visionary creation is suitable for armies, passenger and cargo transport, rescue operations and sporting events. A vehicle that can travel quickly on land, ice and water is definitely a wicked invention. Sir Christopher Cockrell's creation may seem like a swirling, complicated system of expensive and powerful engines, but we are going to show you how to make your very own hovercraft out of a few everyday items. We have come to the Wicked Inventions aircraft hangar to build our own fantastic flyer. To start, your materials. You will need wood, screws, string, a marker, spray adhesive, stapler, a shower curtain, and that firm DIYing favourite, gaffer tape. To begin, we'll need to cut a large circular disc from our piece of wood. Tap a screw into the centre of your wood and use a marker pen and a piece of string to draw the circumference of your disc. Next, carefully cut out your wooden shape with a jigsaw. At one end of your disc, draw and cut a hole to fit snugly around the power source for your personal hovercraft. More on that later. Now for the skirt. Take your shower curtain and place it underneath the round board, and then pull it over the top of the wood and carefully staple the material to the top of the disc. Cut off the excess to leave you with a neat finish. Go along the edge of the shower curtain with the gaffer tape to create an airtight seal. Now flip the craft over and admire your handiwork. We actually need some of the air to escape from the skirt, so mark and cut 6 holes equally spaced into the shower curtain, and use more gaffer tape to reinforce the hole's edges. Don't forget to add an additional small round piece of gaffer tape wood to protect the underside of the craft. We are almost ready. we just need power. Step forward the biggest industrial-sized leaf blower money can buy. Snugly fix the leaf blower into our pre-cut hole and we are ready for blast-off. Or should that be hover-off? With an additional wooden ring to reinforce the top, our cockerel-inspired craft is complete. But will it actually work? Well, in a word, yes. With the leaf blower providing the wind power and our production team the forward motion, our intrepid tester has actually created his own personal hovercraft. Flying around the hangar on a cushion of air, we have a revolutionary low-cost transportation method up and running. And is it now ready for the rigours of cross-country travel? No. From the ancient times of the courageous Greeks to the local high-tech gym of the 21st century, we have been on a never-ending quest for fitness, health and beauty. That quest has led us to develop groundbreaking workout programs, nutrition plans and equipment. It is that equipment that allows us to stay fit, strong and healthy. And it was that equipment that has allowed our dreams of space exploration to become a reality.
Cardiovascular exercise is an excellent way to increase your vitality, to reduce fat and burn fat, to manage stress, to lower cholesterol, to reduce your blood pressure. And in many cases, it's a great treatment for the avoidance of or management of diabetes.
It is said the birth of the Western civilization took place in ancient Greece. Democracy, thought exchange and dramatic arts are just some of the wonders this timeless people gave to the world. The Greeks created the ancient games, where a group of young men competed naked in several sports, in order to encourage aesthetic appreciation for the male body and as a tribute to the gods. The Greeks invented several tools to help their athletes, such as barbells made out of stone and wood, and the pull-up bars. Since then, different civilizations saw the benefits to their military in the use of equipment for exercising, and as a result, those tools were massively developed. And when it came to prepare men for the greatest adventure of our kind, the journey into space, NASA built upon these ancient Greek fitness techniques to prepare their astronauts to combat the effects of zero gravity.
When you're in space, you don't have any gravity present, and therefore your muscle and your bone density reduces over time as it's not working against any resistance. So whilst we're on Earth, when we're even walking around, let alone doing any exercise, we're working against gravity, and that helps to produce our muscle bulk and strength, and also our bone density. When you're in space, you don't have that resistance. And even during doing exercise in space, you'll still reduce your muscle bulk and your bone density over time to about 0.4% to 1% every month that you're in space. So it's very important for astronauts to do exercise in space to help reduce that.
Today, gym equipment is not just limited to the simple barbell. There is a wide variety of computer-controlled treadmills and running machines that can aid your workout. An example of this high-tech fitness gadgetry is Precor's EFX elliptical trainer, which is made in their American factory in Washington State.
It was the first elliptical on the market, and ellipticals create a weight-bearing exercise, just like walking or running, but they eliminate the impact. The two foot pedals reciprocate, adding to this natural chain motion, so that as one pedal falls down and around the bottom of the ellipse, the other pedal is going up and creating this natural rhythmical motion.
At the heart of the elliptical trainer is a system of circular pulleys which are worked by the user's movements. And the subassembly of these units is the first stage in the construction of the machine. To begin, the pulley, shaft and pillow block bearings, which connect the shaft to the drive unit but allow it to spin, are assembled. The bearing and the pulley are then aligned to the drive frame and secured. Then the crank arms are fitted. Later in the production process, these will be attached to the stair arms. Next, as the EFX is electronically controlled, a generator is installed onto the pulley, and the belts are aligned before being thoroughly tested by hand and machine to make sure the tension is correct. A resistor that regulates the power to the machine is secured to the unit before being taken to a cart so it is ready for the next stage of assembly. The main EFX frame has previously been welded together. An operator now attaches its feet and takes it to the production line. The new drive is fixed onto the frame, and a second operator laces all the electrical components together for the generator and the battery, while the outer covers are also fitted.
Our products are constantly being evolved and re-engineered to reduce cost, increase quality, and add new features. Every time we do that, it changes how the product goes together. So these folks on the line are held responsible and love being responsible for adding value in that environment and passing on a product that they know is going to be of the highest quality.
The steps of the trainer can be inclined to create a tougher workout for the user, and further down the line, the lift motor and battery that power this functionality are fixed onto the frame. The next stage is to provide the EFX with its high-tech display and heart monitoring features. A new welded display unit is taken from the line, and the internal wiring for the display is threaded inside. The unit is then passed on for the heart rate monitors to be fitted and tested before being wrapped and added to the completed machine later.
It is the responsibility of everyone who puts this product together to have a responsibility for the efficiency and the quality that goes into the build. Our engineers work really, really hard to work with their counterpart on the manufacturing floor, the manufacturing engineer, to make sure that we'll do whatever we need to do on the assembly line, but that this thing flows smoothly down the assembly line.
Back at the EFX frame, two operators attach the ramp, which provides the incline feature for the trainer onto the unit. The ramp is connected to the lift motor by a long metal threaded bar, and then the stair arms are installed into the ramp and also connected to the crank arms at the rear of the machine. Before the EFX is completed, the Unix accessories kit is gathered and taken into the pre-core testing booth, where the trainer's features are tested and its build quality checked.
Every one of our products is tested by somebody on that line in a test booth. It's a sound room. They can listen for noises, they can test the different electronic features on the product, but every single piece that leaves here is tested by a human being.
Once the new EFX machine has passed all the tests in the booth, it is released and is finally ready for packaging. All the key components are wrapped before being securely fastened onto a pallet. It is then taken off the line, and all the remaining accessories are also added, fastened to the pallet and boxed, ready for delivery. Invented by the ancient Greeks, used by the military and NASA, and now being expertly built for use in your home. Gym equipment, truly a wicked invention. So there you have it, a dash through the hidden history, super science, and amazing manufacture of products that you use every day, but have never realised their amazing background. The flag, the hovercraft, and the gym machine. All wicked inventions.